Okay, let's take a look at problem 5, but before we do that, let's go to this little blurb. It says another way to simplify a radical expression it's called rationalizing the denominator. And you rewrite the expression so there's no radicals in any denominator and no denominator in any radicals, which means that I don't have a radical in the denominator. So, for example, if I have 1 over the square root of 2, I can't have the square root of 2 in the denominator. That's just a rule. We cannot have it. So I'm going to multiply the top and the bottom by the same number, and preferably by a number that's going to get rid of this square root. So square root of 2 times the square root of 2, I'm just removing the radical and I get 2. So 1 times square root of 2 is the square root of 2. So let's look at an example. It says, what is the simplest form of the cube root of 5x squared divided by 12y squared z? So I have the cube root of 5x squared. So I have the cube root of 5x squared divided by, and they just broke it down, and they broke all of the numbers down too. So we know that we have 2 squared times 2 squared, which is 4, by the way. So 4 times 3, we know that's 12. And so they broke that down. Then we have y squared and we have z. And so now I want to make sure I get this cube to go away. So in order to make this 2 cubed, I need to make it multiply by another 2. In order for it to be 3 cubed, I need 3 squared. In order for it to be y cubed, I need a y. In order for it to be z cubed, I need a z squared. And so that's why we multiply the numerator and the denominator by the cube root of 2 times 3 squared y z squared, so that all of this goes away. And so I'm left with, okay, so when I do that, I get the 2 out, the 3 out, and the yz out. And at the top, when I multiply, I have this 2 times 3 squared, which is 9. So 9 times 2, which is 18, times 5 is 90, times my x squared that was already there, times the new y, and times z squared is what my numerator looks like now. And so this can't be broken up in any other way, so this is now in simplest form. So the correct answer is A. Okay, so now let's take a look at, I got it. So we have the cube root of 7x divided by the cube root of 5y squared. So I'm going to multiply top and bottom by a number that's going to get rid of what I have in my denominator. So I know that in order for this 5 to go away, I need 5 squared. So 5 times 5 squared gives me 5 cubed. And I need a y. So y squared times y gives me y cubed. So whatever I do to the bottom, I have to also do to the top. So now when I multiply, I get the cube root. At the top, I get 7 times 5 squared times x times y all over 5y, because it goes away now, because I know that I just took the cube root. Or just for the people that want to see that, let me break it down. So 5 cubed y cubed. Okay, so we get so 25 times 7 is 175. So I get the cube root of 175 x y, and at the bottom I can take the cube root of all those numbers, so I get 5y. And so it stays just like that. That's as simple as it gets. For part B, it says, which choice in problem 5 could be eliminated immediately? Explain your reasoning. Let's look. Oh, I see a choice B could be eliminated immediately because it has a radical or a square root in the, not a square root, it has a cube root. It has a radical in the denominator, and we cannot have radicals, so we know B was not the answer. So I hope that this helps.